Now, moving on to multiple spring systems. So, spring mass systems can basically be arranged in two ways: the parallel combination and the series combination. As you can see in the first figure, in a series combination, the force acting on each string is the same, but the displacement on each string will be different. So, the extension x will be equal to x1 plus x2 plus x3. Since the force applied on each string is the same, we can say that F is equals to F1 is equals to F2. और अगर हमने इसका स्प्रिंग कांस्टेंट निकालना हो so we'll do 1 over k is equals to 1 over k1 plus 1 over k2 since the force acting on each spring is the same but the displacement on each string is different. And then we can write the formula for force as F is equals to minus kx. Now, looking at the parallel combination of springs, in the second diagram, we can see that the displacement acting on each spring is the same, but the restoring force acting on them is different. So now F will be equal to F1 plus F2. And since the displacement is the same, to calculate the spring constant, हम simply k's को add कर देंगे, where k is equals to k1 plus k2. And hence the extension x will be equal to x1, which will be equal to x2. So hence we can conclude by saying that in a parallel system, multiple strings are arranged alongside each other and each spring will experience the same amount of force when a load is applied on it. But in a series system, multiple springs are connected end to end with each other, which means that the load is distributed among the springs. And so the series system allows for a greater total displacement when a load is applied. But the series system will have a lower spring constant because the same force is applied across all the strings. And the parallel system will have a higher spring constant because the same displacement will be applied across all the strings.